All right, let's take a look at section 4.4 on the trigonometric function of any angles. So in this particular section, we'll take a look at how to evaluate trigonometric function of any angle and find the reference angles, and then also learn how to evaluate trigonometric function of any real numbers. Okay, so first of all, let's say we have an angle located in any quadrant, right? It could be first, second, third, or fourth. For example, this one is located on the second quadrant. So in order to find out sine theta, cosine theta, you need to form the right triangle here. Draw a perpendicular line from the point towards the x-axis and form a 90-degree angle here, form a right triangle. So now here, and this angle theta, this is theta prime. It's what we call reference angle. So for this angle, we use the reference angle to find all 6 trig identities. This is x coordinate, so this is x goes here, y goes here, and then this is the r. Since that's it's a right triangle here, so Pythagorean theorem applies here, meaning r squared equal to x squared plus y squared, and the r is always positive. So radical x squared plus y squared. Okay, so we get a value for r. And now sine of this angle will be y opposite over hypotenuse, sine theta equals y over r. And cosine theta is adjacent over hypotenuse, so x over r. Tangent theta is opposite over adjacent, y over x. Cotangent theta is adjacent over opposite. Secant theta is a reciprocal of cosine theta, so you get reciprocal of that, you get r over x. And then cosecant theta is reciprocal sine theta, so r over y. So this is basically how we evaluate all 6 trig functions for any angle. This angle could be located in any quadrant. And because r is equal to radical x squared plus y squared, cannot be 0, also it's non-negative, so this is always positive. This is very important, right? R is always positive. And then when x equals 0, then tangent and secant of the angle theta are undefined, because for tangent is y over x, and the secant is r over x. So anything with the denominator r, x, then that will be undefined. So this is y over x. Secant theta is r over x. So when you see the denominator x, and when x equals to 0, then undefined, right? Both of them are undefined. Any number divided by 0 is undefined. Similarly, when y equals to 0, then cotangent is x over y. Cotangent theta equals x over y. Cosecant theta is r over y. And when y equals 0, then they both are undefined. Any number by 0 is undefined. So this is basically give us idea how these things plays out for those special angles. And now let's take a look at this. Let -3, 4. So here x coordinate is -3, y coordinate is 4. We're pointing on the terminal side of the angle theta, find sine, cosine, tangent. So first of all, you plot this, right? If you plot it, you'll see that it's located in the second quadrant. So now next step is draw the perpendicular line towards the x-axis. You form a right triangle here. So this is -3 units here, and this is 4 units here. And basically, we need to find out the r. So r is r squared equal to -3 square plus 4 square. So r square equals 9 plus 16, which is 25. And then r is equal to radical 25, positive one. Right? R always got to be positive, so r equal to 5. Now if you know r, this is 5, then you can easily find the sine theta. So sine theta here, this is our that will be we'll call this reference angle. And sine theta is opposite 4 over hypotenuse, so it's 4 over 5. Cosine theta is adjacent 3 over 5. Tangent theta is opposite over adjacent, so 4 over -3. So -4 over 3. So that will get that. If you want to get the other 3, just use a reciprocal to get the other 3. But they only ask for sine, cosine, and tangent. That's how you basically solve any given ordered pair, right? A given point, you'll be able to find any trigonometric functions for that particular angle right here. So also we can verify this easily, right? Using the mnemonics, all student. So in the first quadrant, all of them are positive. Second quadrant, only sine are positive, right? You see, this sine is positive. And tangent and tangent here is opposite over adjacent, so -4 over 3. But using the mnemonics, all student, meaning in the second quadrant, only sine is positive. Sine is positive. The other 2 is negative, right? So we check that. Cosine and tangent are negative. Yes. You can use the mnemonics to quickly check your answer. All right, so now let's take a look at this. Let's say, remember, we already mentioned this in the last lesson. In quadrant 1, all of them are positive, right? Sine, cosine, tangent, they're all positive. So that's why we call all students, all of them positive. Second one, sine, right? Student, sine. Sine is positive, the other 2 is negative. Third quadrant, take t, right? Tangent is positive. Okay. And sine, cosine, negative. And the fourth quadrant, calculus C. Okay, so cosine, positive. And the other 2, negative. So all students take calculus. Help you quickly, remember all these different trig identities. Now let's take a look at the reference angle. So actually, we already used the reference angle in the previous example in order to find those trigonometric function. And reference angle is basically, let's say we have angle theta here. Angle theta could be anywhere, right? Could be in let's say in the third quadrant. This is angle theta. The whole angle is angle theta. And the reference angle is the angle between the terminal sine of the angle and also the x-axis. So that angle is what we call this angle right here is called theta prime. And this is what we call the reference angle. So it's the intercept of the terminal side of the angle and also the horizontal axis. So this is the angle theta prime here, and we call this reference angle. Always, right? X-axis, horizontal axis, terminal side for the reference angle. So right here in the second quadrant, that will be terminal side. This is terminal side of angle, and then x-axis, and this angle is what we call theta prime, reference angle. Third quadrant will be x-axis, terminal side for the reference angle theta prime. Fourth quadrant, similarly, horizontal axis and also the terminal side of the angle, and for the reference angle theta prime. And typically, if the angle is located in the second quadrant, you can use pi minus theta, reference angle pi minus theta, or 180 degrees minus theta. And if it is in third quadrant, reference angle equal to angle theta minus pi, or theta minus 180 degrees. If it's in fourth quadrant, use 2 pi minus theta, or 360 degrees minus theta. Either way you like. Right? Depends on which measurement you decide to use. And reference angle for theta equal 300 degrees. Again, 300 degrees located in the fourth quadrant. So 90, 180, 270, 300 degrees. So this whole thing is 300 degrees. So using 360 degrees minus the reference angle here, theta prime equal to 360 degrees minus 300 degrees equals 60 degrees. Okay. So this is for pi b. Similarly, 2.3 radian. Okay, so 2.3 radian. So if you look at this is 0. This is pi over 2 radian. Pi radian. Pi radian is 3.14. Pi over 2, that's approximately 1.57. 2.3 must be in between. Right? So this is 2.3 radians. So again, this angle theta should be expressed as pi minus 2.3 radian. So theta prime equal to this. The third one is negative angle. That means it's located in the, we're going counterclockwise, negative 90 degrees, negative 180 degrees, it's negative 90 degrees, negative 135 is in between. So again, reference angle is between terminal side and a horizontal axis, x-axis. This is reference angle. So you do negative 135 degrees minus negative 180 degrees. This angle should be 45 degrees. So reference angle equal to 45 degrees. Again, there are detailed explanation from this. Similarly, you should definitely always draw the locate the angle and use some trigonometry identities to get the reference angle. First one 60 degrees. Second one is pi minus 2.3 radian. And if you want to put in the radian measurement with 0.8416. And that's how we get that. Third one, so it's located in the third quadrant, and if this is negative 135 degrees, then the positive angle should be 225 degrees. You can also use 225 degrees minus 180 degrees to get a reference angle right here. That's what they do. 225 degrees minus 180 degrees equal 45. It's probably easier using the positive angle. Given condition that, given that 225 degrees is equal to a negative 100, they have equivalent angle. Means exact same angle. Now let's take a look at trigonometric function of real numbers. So for example, we have a order pair right here, x, y. So in order to find the hypotenuse, we're using Pythagorean theorem. So r equal to radical x squared plus y squared. Okay, so this is hypotenuse. And then we could define sine, cosine, and tangent using this reference angle. Okay. And then we define sine theta, cosine theta, and tangent theta from earlier slide. And also one thing is we want to make sure we have the right proper sign for this. So you just use that mnemonics to guide you, meaning all students take calculus, and then you will give you the guidance in terms of the sign, because the sign is very important. So in order to evaluate trigonometric function of any angle, find the value of trigonometric function of any angle theta, determine the function value of associate reference angle. So reference angle is needed, and depends on the quadrant, which theta lies. Then we put appropriate sign to the function values. And so for your convenience, you should try to memorize all these special angles like 0 degree, 30 degree, 45, 60, 90, 180, and 270 degrees. And that's a radian, that's degree measurement, radian equivalent. Get these radians. So the sine 0 degree is 0, sine 30 degree half, sine 45 radical 2 over 2, sine 60 is radical 3 over 2. Sine 90, that's 1, sine 180 is 0, sine 270 the same thing, because it's the same thing as negative sine 90 degrees, because sine is our function. Yeah, so negative 1, sine 90 is 1, so it's negative 1. So we have all of this, and then also cosine thing. So cosine 0 degrees is 1, cosine 30 degrees radical 3 over 2, cosine 45 degrees is radical 2 over 2, cosine 60 degrees is half, cosine 90 degrees 0, cosine 180 degrees is negative 1, cosine 270 degrees equal to cosine 90 degrees, so they're both equal to 0. And you can find a quotient, right? Use the quotient of these two, 0 over 1, you get tangent. Half over radical 3 over 2, get radical 3 over 2. Radical 3 over 3. So use the previous result. 1 over 0, sine 90 degrees over cosine 90 degrees is 1 over 0, that's why it's undefined. And 0 over negative 1, that's 0, negative 1 over 0, again, it's undefined. So tangent 270 degrees and tangent 90 degrees are both undefined. Okay. Now let's take a look at how to find cosine 4 pi over 3. Again, let's locate the angle. So 4 pi over 3. If you want to turn this into degree measurement, you can do pi equal 180 degrees over 3. So this is 720 degrees over 3, 240 degrees. Definitely it's located in the third quadrant. And also let's determine this. Negative 210 degrees. You can just add in that by 360 degrees. So it's 150 degrees. That's why it's located in the second quadrant. By adding one revolution, we get the equivalent angle on the positive side. So 150 degrees, definitely it's the second quadrant. And then for cosine 240 to the third quadrant, cosine is definitely negative. So at least we know the sign. Second quadrant for tangent in second quadrant is also negative. Tangent is positive on the first and the third quadrant. Cosecant 11 pi over 4. And then you can turn this as 180 degrees over 4. So that's going to be 45 times 11, 495 degrees. $495. And in order to get a reference angle, you need to subtract 360 degrees to get 135 degrees. And this is again is in the second quadrant. In the second quadrant, only sine is positive, so cosecant is also positive. So definitely, it's positive. Okay. So by narrowing down determine the quadrant, and then you'll be able to find out the sine. And after that, use the reference angle. Right? So reference angle is pi over 3 here, also 60 degrees. But sine in the third quadrant, cosine in the third quadrant is negative. That's why cosine 4 pi over 3 is equal to negative. Cosine pi over 3, so it's equal to negative half. So sine, determine the sine first. Now after that, use a reference angle to get a number, to get the answer. Because reference angle is always a Q angle. Remember, reference angle. So using the reference angle, you get a trig identity is always positive because it's a Q angle. So we determine the sine, put the cosine pi over 3, and get a final answer. Negative half. Cosine 60 degrees, it's equal to negative half. The second angle is you add in 360, you get 150 degrees. As you can see, this is 150 degrees. All right, then the reference angle is equal to 180 degrees minus 150, which is 30 degrees. And also we know that tangent in the second quadrant is negative. So tangent of negative 210 degrees is the same thing as tangent of 150 degrees. So that's second quadrant, tangent is negative. Only sine is positive. So negative tangent of 30 degrees, reference angle is 30 degrees, tangent 30 is radical 3 over 3. Okay. And you find the solution here. And the last angle is 11 pi over 4. Again, 11 pi over 4, it's equivalent to 495 degrees. If you feel like degree measurement is easier, then subtract 360 degrees to get 135 degrees. And we know this is 135 degrees. So reference angle must be 45 degrees. So again, in the second quadrant, cosecant is positive because sine positive, then cosecant is positive. So it's equivalent to cosecant 45 degrees. It's equal to 1 over sine 45 degrees. Sine 45 is 1 over radical 2 over 2. That becomes 2 over radical 2. And you rationalize that, end up with radical 2. So cosecant 45 degrees equal to radical 2 here.